and Assalamualaikum. Today, my groupmate and I will present about the environmental analysis, which the case that we will focus on is the soil pollution. So, my first groupmate Azalia will present about the problem statement, and the next one Shafiqa will present about the example cases and also analytical technique, while me, Nadia, will present about the recommendation and also introduction. Lastly, Amira will present about instrumentation and also conclusion. Firstly, let us start with an introduction. So, the focus on our presentation today is about the environmental analysis. This analysis actually plays a crucial role in understanding and addressing pollution, and is also a significant challenge affecting the ecosystem, human health, and also the overall well-being of the planet, such as the ozone layer and also the other things. So when we talk about the pollution, it is actually an introduction of a harmful substances or contaminant that give a major bad impact on our natural system. So the focus on our presentation today is about the soil pollution, which is one of the environmental analysis that we could do.
Some of the most prevalent environmental issues come in the form of pollution. Pollution can permeate all aspects of the environment, from air to water or from water to soil. So, pollution is caused when toxic elements are released into the environment and can have an adverse effect on the system present. So, human activities like fracking are damaging to nature and contribute to multiple forms of pollution. So, with the technique of analytical chemistry, perhaps gas chromatography are able to help in detecting pollution in soil.
Example of soil pollution cases in the world was like what happened in China and India, where a company named Oil and Natural Gas Corporation was reportedly contributed to soil contamination in the area when there were hydrocarbons released during oil extraction or refining due to leak of pipelines. Secondly, example of cases which contributed to soil pollutions reported by the UN were like the industrial pollution, mining, farming, and poor waste management, with the polluter pays principle absent in many countries. And last but not least, another case of soil pollution was studied for the polycyclic aromatic hydrocarbons in suburban vegetable field soils of Changchun, northeast China, which pose a huge potential risk for suburban agriculture. To help with detecting soil pollutions, the analytical technique that can be used is the gas chromatography technique. Gas chromatography allows the separation and identification of volatile organic compounds (VOCs) and semi-volatile organic compounds (SVOCs) present in soil samples. By utilizing gas chromatography, insights of the types and concentrations of pollutants present in the soil are gained to assess the extent of soil pollution, developing effective remediation strategies, and monitoring the progress of cleanup efforts. There are steps to be followed to detect the pollutants in soil. Firstly, the sample preparation. The soil sample collected from contaminated sites is extracted from the soil matrix. Secondly, it's about the instrumentation. The extracted compound then introduced into the gas chromatograph. Thirdly, the separation phase. The different compounds separated based on their physical and chemical properties. Fourthly, the detection. Detectors such as FID generate signal that will convert into chromatograms. And lastly, the data analysis. The chromatograms being analyzed and the contaminants present in the soil sample are identified.
Flame ionization detector, short form is FID, is a widely used method to detect total petroleum hydrocarbon (TPH) in a sample. The principle of the FID is based on the combustion of organic compound in a hydrogen flame and the detection of the resulting ion by an electron in the flame. When a sample containing TPH is injected into the FID, it is first mixed with hydrogen gas and then introduced into the flame. The high temperature of the flame will break down the hydrocarbon molecules into a simpler and more reactive species, including positively charged ion and electrons. The positively charged ion are attached to a negatively charged electrode that are located close to the flame. As the ion approaches the electrode, they cause a flow of current which is proportional to the concentration of hydrocarbon. In this way, FID is able to detect and measure the total hydrocarbon content in the sample, including those are not specifically targeted by the analysis. However, it should be noted that FID cannot distinguish between different types of hydrocarbons, and therefore, the result obtained for the FID analysis may not be ineffective the exact composition of the sample.
To gas chromatography, there is a few recommendations that we could use to detect the soil contamination, such as HPLC, ICP, MC, and also FTIR. So let us talk about the first recommendation, which is HPLC, the high performance liquid chromatography, where this technique is used to separate and analyze a wide range of non-volatile organic compounds, including the pesticides, herbicides, and also other organic contaminants. Secondly is the ICP-MS, which is the inductively coupled plasma mass spectrometry. This technique is used to detect and quantify the heavy metals and trace the element of the soil sample. This ICP-MS offers a high sensitivity that can analyze multiple elements simultaneously, and also this technique commonly used to detect the contamination of metals in the soil. And last one is the FTIR, which is the Fourier transfer infrared spectroscopy, which employed to analyze the organic functional group that present in the soil sample. This FTIR provide the information about the presence of organic contaminant inside the soil.
In conclusion, gas chromatography is an effective method for identifying soil pollution. It is suitable for identifying and measuring contaminant in soil samples due to its capacity to separate and analyze organic components.